All right, we're going to do a crash course in soils. Certainly not everything you need to know, but going to hit on some of the major points. First thing with soil, just a reminder not to call it the D word. Calling it dirt implies that it's a pretty simple topic, and really soils are quite complex. We'll start by talking about the four things that we look for or look at when we're looking at soils. The first being mineral matter being really important to plant growth. We'll get more into that in a little bit. Organic matter, so we're talking things like certainly the leaf litter that's here, twigs, dead organisms, animal waste. And we'll get a little bit more into those when we get into soil formation in just a moment as well. Water, soil moisture was something that we looked at in our soils labs, and certainly the amount of water in a soil, or the amount of water that it can hold or let pass through, is determined by the spaces between the particles that make up that soil, and where we have those spaces we're also going to have air. So speaking of particle size, we're going to talk about major soil categories based on particle size just for a moment, and those would be gravel, sand, silt, and clay. Hopefully you can hear me over my incredibly loud washing machine tonight. Gravel being the largest in particle size of those four, and then followed by sand, silt, and clay being the smallest. Because gravel is the largest, between it we're going to have the greatest amount of space or airspace. So we'll call that porosity, or it's a more porous soil particle size than clay, which is going to be quite tightly packed together. There's not going to be a lot of space between the particles. Because gravel is more porous, water is going to flow through it more easily, and we call that a more permeable type of soil, whereas clay isn't going to allow water to move through it as easily. But typically when we're looking at soils, soil categories, we're looking at something a bit more complex. And the soil series are what we usually talk about, and there's a website that you need to check out here with an activity to go along with it. But this is from the Web Soil Survey, and right here is what we call a soil survey map. There's about 21,000 soil series in the country, and something like 3,000 or so in the state of South Carolina alone. Why are we looking at soil surveys? Why would this be helpful? Why would anyone want to know this? It helps you understand where you could build, what kind of soils you could put, say, a septic tank on, what types of things you can grow in an area, or where you can grow things. So looking at soil maps in these soil series is quite important, and in fact there is an app for this as well. So, moving on to the soil horizons. Soil horizons I want to talk about just for a minute, and I know your lab spent a lot of time on this, but just as a reminder, the O layer is your organic layer, and this is going to be made up of leaf litter, roots, twigs, and in cultivated fields you don't usually find an O layer. A layer is your topsoil, and that's going to be that nice, dark, loose, crumbly material. It's also the most productive layer typically of the soil. B layer here is your subsoil. When we look at this, it's going to be lighter in color, more dense, lower in organic matter. And then down here, this C layer is the subsoil. And the B horizon forms from the C horizon weathering over time. So soil formation, speaking of, a little distracted here, looking at a couple notes and reminders for myself. Soil formation can best easily be remembered with by CLORPT, C-L-O-R-P-T, and the L's a bit mysterious, and I'll get to that in a minute. But the C stands for climate. Think of the Arctic versus equatorial areas. Decomposition happens a lot slower in colder climates. Think about say the forest versus the desert. There's going to be a lot more, because of more rainfall, there's going to be a lot more organic matter available in the forest than there would be in the desert. So areas like the southeast, where we are, because it's nice and warm and we have a lot of moisture and it's wet throughout the year, we get very well developed or deeper soils here. Now the C is for climate, and I learned that the C and the L come from climate. There's another way to look at where the L comes from, and that's L for living organisms. However, the way I learned it was C and L were climate and O was organisms, however you want to remember it. But with organisms, we're talking plants, burrowing animals, insects, microorganisms that live in the soil, your decomposers. Those things are certainly going to play a factor in what kind of soils develop and the speed of the soil development. R is for relief. In relief, we're talking as you go down a slope, or topography rather, of the land. So from a high area on the slope to low-lying areas. And typically your areas higher on the slope are going to be better drained. And your low-lying areas are going to be wetter, even swampy in some cases. In this case, this is labeled, well, no, I guess it's not. But at any rate, along with relief, in topography, think about concave versus convex areas. Concave areas are going to allow water to pool up in them, whereas concave areas are going to allow water to run off. And certainly water plays a big factor in soil development. The P is for parent material. With parent material, soil formed on limestone is going to be less acidic than soil formed on granite. So depending on what's underneath and how that B horizon forms, that's going to determine some of the characteristics of the soil that you're dealing with. And the last one is T is time, and I didn't really have a graphic for that. But soils take a long time to form in general, and the more time that passes, the more horizons that form. So with soils, it's just a quick crash course. Please remember to review your other materials as well, but hopefully this provides you with a quick overview.